Here we're going to talk about proofs. We're going to get into two-column proofs, as you can see here, and we're going to use the different properties of equality to help us with those proofs. Many of these you already know of, you probably just haven't put a name to them. I think of your different properties of equalities or your different reasons and proofs as ways to kind of plead your case. You can think of it as being in the courtroom and you have to plead your case to the judge. You have to have reasons to back up everything you're saying, otherwise it's not going to hold up. And the same thing's going to happen in a proof. So our first property of equality, which would also work as a property of congruence, would be the reflexive property. And all this is saying is a number, could be A, we're going to call it A for now, is equal to itself. So you could replace this with 5. It's going to say 5 equals 5, or 7 equals 7. When you go to get into congruence, it would say, an example of this would be segment AB is congruent to segment AB. Pretty straightforward. Something's going to be equal to itself or something's going to be congruent to itself. The next one is the symmetric property. Again, we're going to work with numbers. My numbers, I'm going to call them A and B as my variables, which says if one number equals another number, then B is going to equal A. So just all this is doing is switching the order. And a lot of times you'll see it in this kind of format in terms of a variable equaling something else. So 5.3 equal to x, well, we can flip it around and say that x is equal to 5.3. Not any different. Then you get to the transitive property. Now you're looking at three different things. Here we have A equal to B, and then you get B equal to C. Well, if that's the case, then you're going to know that the first and the last will also be equal, and A equal to C. A little example of this, every house has a clock, and then in every clock lives a mouse. So therefore, every house lives a mouse. Hickory dickory dock. Now you have the addition and subtraction properties of equality. In this one, you can look at an equation like this, and we'd need to solve it. And to solve this equation, we would add 7 to both sides of the equation, something you've done before in the past. This step right here, where we added 7 to both sides, that's referred to as the addition property of equality. Notice, very similar to what's going on in the red here. A equals B. That's my x minus 7 equal to 2. Well, I added the same number to both sides, C. In my example, that C is like the 7. Added the same thing to both sides, and then when you finish your equation, obviously, you'd have x equal to 9. Now, the subtraction property is the exact same thing, just you're going to subtract a number instead of add it. So if we add something to both sides, call it the addition property of equality. If you subtract something from both sides, call it the subtraction property of equality. Kind of in that same notion, we'll go on to the multiplication and division property. The equation that I have here, notice first we'd have to use the subtraction property of equality. And now we'd be left with 3x equal to 6. Now this is where the division property, most of us would use the division property of equality, and I just did that totally wrong, didn't I? So let me fix that. So we'd use the division property of equality. We're going to divide both sides of the equation by 3, and when everything's all said and done, we'd have x equal to 2. But this step right here, that's referred to as the division property of equality. Now, we could have used the multiplication property of equality. Instead of dividing both sides by 3, we could have multiplied each side by 1/3, and then you'd have had the multiplication property of equality. So multiplication and division property, really one and the same, just depending on whether you're going to multiply or divide. Now the substitution property. I'll click the box and make everything go away. A little lengthy, I know, but it's really a pretty short property. It's just telling you that if you know that two numbers are equal, in this case we have our A and our B being equal to each other, then A may be replaced by B in any equation. In other words, just wherever you see an A, you could put a B. So in the example here, we have 7A minus 22 equal to 17.A, but because A and B were equal to each other up here, we can take that A down here and replace it with B. And now you have 7b minus 22 equal to 17.8. So there's the one example there. When you come over here, we started with this equation that says 4 over 2y equals 6. Well, all we're going to do is we're going to take this 4 over 2. That's equal to 2. So we can replace the 4 over 2 with 2 because those two things are equal. Another example of substitution. The distributive property, I think you've seen that one before. You have a little example over here showing it. But it's just telling you that when you have a bunch of numbers like we do in A, B, and C, and they're set up like this, we can multiply that A by everything inside and now have A times B and A times C, and they're still added together because they were added together here. And this is just another example over here showing all that very similar. That's in an equation. And I'm going to stop here, and we'll get to these examples in another video.